Let us learn the division algorithm. Algorithm means it is the methodical step by step procedure of calculating the result. Okay, till you get step by step you have to do, that is the algorithm. Understood? Methodical step by step procedure. Don't change the steps. You have to do the steps correctly till you get the answer. Okay, how many steps you needed, you have to do. You cannot stop within one or two. Understood? It is the meaning of algorithm. Euclid's division algorithm given by the mathematician Euclid's. Okay, it is using this Euclid's division algorithm we can find out the HCF, that is the highest common factor of two numbers or three numbers easily. Okay, there we have some steps. It is Euclid's division algorithm procedure. We are repeatedly doing the division lemma only. Okay, first you consider the two numbers A and B. Then that numbers you compare which is greater. In that greater number you consider as the dividend and smaller number you consider as divisor. So how to write the division lemma? It is A equal to BQ plus R. Okay, in that R is the remainder, so we can write the relation 0 less than or equal to R less than B. Why we did not write the absolute value? When you find the HCF, there they will give only the positive value. They will not give the negative, so we did not write the absolute value of B. Okay, in this situation, if the remainder is 0, we can say the divisor B is the HCF. Are you clear? Whenever you get two numbers, you check the number which is the highest number. Then the highest number you consider as dividend and the small number you consider as divisor. So using the two relation you write the division lemma. Okay, dividend divided by divisor. You divide and write the division lemma in the correct procedure. Okay, that means if you get 7 divided by 2, how to write? 2 3s are 6, remainder 1. So you can write the division lemma is 7 is equal to 2 into 3 plus 1. Okay, so 2 is the divisor, 1 is the remainder, 3 is the quotient. Okay, in this situation the remainder is not equal to 0, so we cannot conclude the HCF. Okay, in the other situation you see 6 divided by 2. Okay, when you divide the 6 by 2, you know the quotient is 3, 3 2s are 6, so you will get the remainder 0. So you can write 6 is equal to 2 into 3 plus 0. Okay, so the remainder is 0. So since the remainder is 0, we can conclude that divisor 2 is the HCF or GCD of 6. Is it right? Is this a GCD? Yes. Okay, but in this situation 7 equal to 2 into 3 plus 1, so the remainder is not equal to 0, so we cannot conclude the HCF. So you have to continue the division again. Okay, you consider the divisor and remainder. Understood? You consider the divisor and remainder and continue the division like this way, 2 divided by 1. Then when you get this 2 divided by 1, so what you get? 2 1 is 2, remainder 0. Now the divisor is 1, so 1 is the HCF. Sorry, this here I said the HCF of only one number, it is not correct. Two numbers we are considering, HCF of 7 and 3. Okay, we consider the two numbers 7 and 3, no? 7 and 3 first consider, 7 and 2. 2 is the divisor, 7 and 2. Second we consider 6 and 2. Okay, when you consider 7 and 2, first step you did not get the remainder 0. So you again do the same procedure. So the divisor you consider, this divisor and remainder only you consider. In these two, which is greater? Always the divisor is greater than the remainder. So divisor, that means this divisor number 2 is equal to, you know, that is 1 into 2. Okay, in this situation this 1 is the divisor. Here 2 is the dividend. This divisor will change as the dividend. Okay, first step divisor will change as the dividend of the second step. First step remainder will change as the divisor of the second step. Okay. Now in this step, the 1 is the divisor. We got the remainder is 0. So this 1 is the HCF of this 7 and 2. Is it correct? There have no common factors, no? So 1 is the GCD. So we get using the division lemma. Am I correct? It is easy. You no need to do this factorization method using the division lemma if the number is big or small. It's okay. For small numbers, it is the factorization is easy, but for the big number, we don't know which is a suitable number to factorize. This division lemma is easy to find out the HCF. Am I correct? When you do, you will understand. Then what is the third step? You see, thus otherwise. Okay, so if the remainder is not equal to 0, that is the meaning. Otherwise, B, that is the divisor, you consider as the dividend, and R, that is the remainder of the first step, you consider as the divisor. Okay, this B and R the previous step numbers. Q1 and R1 will get in this step. When you divide B by R, you will get the quotient and new quotient and remainder. Okay, in this situation, if R1 equal to 0, now the divisor R is the HCF of the first number. There you don't change the number. Number is which number you taken in the beginning, only that number. Okay, next one. Suppose in this situation also, if the remainder is not 0, continue the same. Remainder is R1. Okay, the divisor is R. So this divisor you consider as the next dividend, and remainder is considered as the next divisor. Okay, like this way you consider and continue till you get the remainder 0. If you have 5 steps, you should do the 5 steps. Till you get the remainder 0, you have to continue. When you get the remainder 0, in that situation of the divisor, in that step divisor as the HCF of the number what you taken in the beginning. Okay, in the beginning, which are the two numbers you are taking, for that only this HCF we are finding. Okay, so this division algorithm is the repeated application of division lemma until we get the remainder, 0 remainder. Okay, easiest procedure for the big number. Yes, now we can continue the illustration.